So very good morning, guys. So fine. So last day we have been discussing on um, application exceptions. So what did I say? Ray, application exceptions means these are thrown by developers. Developers will throw these exceptions. And when developer is going to throw in an exception here, basically, what exception class instance should be created and thrown means I said you there are three options available to you. What are three? You can either create the instance of any predefined exception class that matches your requirement. For example, last day we have just created and thrown the instance of index out of range exception there, where when the error index is outside the bounds, we have just gone for using a index out of bounds exception we have thrown there. Yeah. So the first option, what we just what I shown you is creating the instance of a predefined exception class and throwing. So here, recollect index out of range exception. So when you're giving outside of the 5 values, it has to throw you index out of range exception. Same way here also. Return null, wrong. What is it? Thrown you index out of range. Second option. What is the second option? You can create the instance of a predefined exception class. Which one? Under the second two options are the default constructor, parameterized constructor. If you use the default constructor, what is the error message? Error in the application. We have shown that. Error in the application. So we have defined a parameterized constructor. If we define if we use a parameterized constructor, then what is the error message? Whatever error message we pass, that will be printed there now. Are you clear? And this is a predefined class, guys. This is a predefined class what we have. Actually, how that works here is So we learned about all these things. Finally, two types of exception: system exception, application exception. So how to throw an exception? Through two steps. Which exception class? Three options. If any of the predefined exception class is matching with the scenario, then we can create instance of that class and throw. Second option, create the instance of application except predefined class, passing a customized error message to the constructor and throw. Are you clear? Okay, third option, define our own exception classes. Okay, first one is clear now. Second one we are talking. Application except predefined class. By calling any of its two constructors, create the instance of application exception by calling any of its two constructors and throw. Okay, so under this I'm telling you again, what is that? This class has one default and parameterized constructor. This class has one default and one parameterized constructor. So, and the behavior will be as following. What is that? If we create the instance by calling default constructor, then it prints the error message. What message? As, what is that, guys? Error in the application. Error in the application, which is inherited from its parent class. What's the parent class? That is exception class. Okay, now second option. If we create the instance by calling its parameterized constructor, that is, which takes what? String. Which takes string. What is the string? Error message as parameter. Then when the error occurs, when the exception occurs, it displays. An exception occurs, it displays the given error message. Displays the given error message. Did you catch my point? So two options are there. So first option, you can just go for using default constructor. Okay, by calling default constructor, then it prints the error message as error in the application, which is inherited from its parent class. When we create the instance by calling its parameterized constructor, which takes string as a parameter, then it prints the given error message. Okay. So now just understand, it's a predefined or the defined class? Predefined class, how is it defined? Watch it. How the class is defined? Observe it. Public class. What is the class name? Application exception colon. The class inherits from the exception now, right? Now in this, they defined one string underscore error message. One variable is equals to null. Even I don't give also default value, null, you know that. Okay. Then we have two constructors defined here. What constructor? Public application exception, default constructor. Just a minute. Okay, and here, what is present? Underscore error message is equals to null. If you create the instance by using the default constructor, what is the error message? Error message is null. Okay. Second option, we have a parameterized constructor now. Public application exception. What you can pass? String error message. Come on. Underscore error message is equals to error message. Now see, if you create the instance by calling this constructor, what is the error message? Null. If you create the instance by using this constructor, what is the error message? The given error message. Okay. Now, in every exception class, we have a virtual, we have to override the message property in a public override string message. It's a read-only property. So we have only getter. We have only get accessor. There is no set accessor in the code. Okay. How is the logic implemented? Watch, guys. If underscore error message equal to null, means what is the meaning? Array, you created instance using default constructor. If it is null, what is the meaning? The instance is created by calling default constructor. So the instance is created by calling the default constructor now. Okay. So what is the code, Return base dot message. Base means parent class. That's why see, when I use the default constructor, what is printed on the screen? Error in the application. Are you clear? Yes or not? No, it's not null. It's not null means what is the meaning? The instance is created by calling the parameterized constructor then. Correct? Then what? Return. Return. What? That's it. Understood or not? Okay, so simple. Okay, let me remove the braces here. Single line only now. So it will be much simple and easy to understand. Look at this, all of you. This is the property. Did you understand the code? If error message null means instance created calling default constructor. If error message is null means instance created by calling the default constructor. What are you returning? Base dot message. Base dot message means the parent class message is what you are returning. Else means instance is created by calling a parameterized constructor. Then what are you returning? You're returning the original error message. That is why when I use the default constructor, it printed you error in the application. When I created the instance by calling the parameterized constructor, it printed you actual error message on screen. Is it clearer? Okay. So that is how exactly the logic is implemented under this class. Which class? Application exception class. Okay. To be clear, in the logic that is implemented under application exception. This is a predefined class. Remember that. We are not defining this class that is already defined. So this is how it is defined. So this is how the logic implemented. Is the second thing clear? Come on here, be active. That's what I'm telling you. Are you clear? Okay. So just this is the second option, what we just have. Third option. The third option is define your own exception class. I already said you guys in the last session, what is this? When I run this code, $100, 0, I'm getting an exception. What is the exception? So see, look at this, all of you. Here, if you just correctly observe, is the error message, is the class name describing about the error or not? And also, the error message is describing about the error. Both are describing about the error. Correct? Okay. So if you just observe this one, in this particular context, the error message and the class name, both are going to describe about the error. Am I right? That is also describing, this is also describing about the error. Both. Okay. And when you get this one, 105, now also exception rises now. Instead of written the code for it. Is the error message describing the error? Yes. Value to divisor cannot be an odd number describing. But class name is not describing, see? Are you clear? So if you want your class name also to be describing, if you want your class name also to be describing here, what you do? You go for defining your own exception classes. You go for defining your own exception classes. Then now the question arises, how to define a class? We already talked on it. If at all you want to define a class, we already analyzed, guys, 2 steps. Step 1. Define a class inheriting from any predefined exception class. Step 2, override the message property and enter the error message you wanted to display there. The first step is just going to be define a new class now. Okay, let's define a class. Just like divide by 0 exception, can I define a class called divide by odd number exception? Yeah, my plan is I want to define a class divide by odd number exception. So watch, guys, in the same thing only I'm writing it. What? Public class divide by odd number exception. And this class should inherit from some exception class. Which one? Anything, no problem. You can inherit from exception. You can inherit from application exception. You can inherit from system exception. You can inherit from any class you want. I want to inherit from divide by 0 exception. Possible. All our exception classes, you can inherit from it. But even though you can inherit from anything, the suggestion what is given is inherit from application exception. Why, sir? Why means, actually, it's not like you're required to inherit from this particular class only. You can inherit from any class you just wanted to. No restrictions for that. It's not like you're required to inherit from this particular class. You can inherit from any class you just want. No restrictions at all. But why application exception is the class what we are using in this particular context is, see, I have said 2 categories of exceptions. One is application, one is system. Under system, Microsoft they defined a set of classes given to us consume. Second category, application exception. That is left empty. That is left empty, telling you define all the classes under the application exception. Did you understand me or not? You define all your classes under application exception. What did Microsoft do? Microsoft defined all the classes under system exception. And the users should define their classes under application exception. They are the chooser. So that the clarity, what is that? All classes under system are predefined. All classes under application are user defined. Okay? So it's not mandatory, but it's only a suggestion. First step is completed. Second step, override the message property. Override the message property here. See, by default, see, when I override the message property, by default, it will be calling you the parent class. It will call you the parent class message property. No, I don't want call. I want to write my own message now. What's it? Return divide by attempted to divide by. There, see, you got a message attempted to divide by 0. Same way I'm writing now. Attempted to divide by odd number. My choice here, I can write whatever I want there. Now come here. See, here, what the first option has shown you? Throw new application exception, default constructor. The one option has shown you. Second option, parameterized constructor. Now third option, throw new divide by odd number exception. Divide by odd number exception. Watch all of you. I'm passing 100 and 10. Any error? No, 10 is not an odd number, even number, no error. Printing you result. Okay. Second option, 100, 0. Any error? Divide by 0 exception, attempted to divide by 0. So class name, error message, both are descriptive. Are you clear? Class is also descriptive. Error message is also descriptive. Both are going to be descriptive in this case now. Error message is descriptive as well as the class name also has become descriptive in this scenario. I hope you guys are clear. Yes or not? So this is how you can just go for customizing up your classes and messages in this process. So this is all about application exceptions. Okay, see, define your own exception class and throw. How can we define our own exception classes? To define an exception class, follow the below process. Step 1. Define a class inheriting from any predefined exception class, but application exception is recommended so that the new class also becomes a exception. Second step. Override the message property and implement the error message we want to display when the exception is thrown. See here, all of you, look at that. Can you understand that? We can define our new class in any of the following way. Option 1. Defined directly under exception class. Now we have 3 categorizations now. One is system, one is application. Now divide by 0. Divide by odd number. Okay. Second option. You can inherit from system exception also. Third option. You can inherit from application exception also, but that is the suggested option. That is the recommended thing. Okay, not only that here, I want to inherit from divide by 0 exception. Yes, I can do, no problem. Yeah, I can do, no problem, because see guys, if you cannot inherit, the parent should be a sealed class. But none of these classes are sealed. All are normal classes only. So you can inherit from whatever class you want. There is no restriction at all. I hope you guys are clear. So this is all about how you define the exception classes and throw it. Okay, guys, I given the notes for you, but still, this is more descriptive. The thing what I typed is more descriptive. Let me add this document also in your class. This. Sonali, huh? Okay. The notes is there why you want. Yeah, this one I just made it a little bit question and answer session. I put it. That's all. Okay. So we just been done with the exceptions and exception handling. Fine. The next topic in our pipeline is delegates. Yeah, the fifth type. We ignored that type now. The fifth type. Let's understand about the fifth type here. What is that? Delegates. So what is this delegate and what is the use of the delegate? Actually, all of you came across pointers in C language. I'm talking with you only. That's why this is making me irritation. I'm talking with you only. Yes or no answer. You learned about pointers in C language, no? So what is the pointer? What is a pointer? You learned in pointers in C language? Yes, sir. What is a pointer? Don't know. You learned of. What is a pointer? Did you learn or not? Answer that question first. Did you learn about pointers in C or not? Stand up, all of you. Stand up. Stand up. Stand until the class is completed. Arey, just talking to you and you don't respond. I'm telling you, I'm getting irritation because of your behavior. Stand like that only. One day if you stand, you'll just get the... So what is the pointer? It is an address of a variable. A pointer is a address of a variable. Basically, that is going to store you the address of your particular variable. So why do we use this pointers means, say, I'm declaring int I is equals to 100. Int I is equals to 100. So what is I? I is an integer which refers to a value. Okay. So I is an integer which is going to refer to a value. Now, we have a concept called pointers. By using these pointers, we can just refer to the address of the appropriate variable. How? Int star p is equals to ampersand I. Int star p is equals to ampersand I. What is ampersand I? Address of I. Ampersand I means address of I. It is going to be the address of I. Now the address of I will come now and store under P. And we call P as a pointer. We call the P as a pointer. Now listen, you can access the value 100 in two ways. You can access the value 100 in two ways now. What are the two ways? One, you can access it directly through I. Two, you can access it through P also. You can access it through I and you can access it through P also. Which one is faster means? Any guess? Which one is faster? I or P? P here. If I is faster, then what do they need a pointer now? P. Address. P directly provides you access to address. When you know the address, you can directly access the value now. So I, when you just refer to I, again you require to find out the address now and then you need to access. But P is directly telling you the address location now. So when you know address, you can directly access it. So accessing the value through pointer is faster. Why? Because it provides a direct access to the memory. Accessing the value through pointer is faster because it provides a direct access to the memory. Okay? Fine. Same like this, we have a concept called as function pointers. Same as this one, we have a concept called as function pointers. What are function pointers? So what are these guys? These are variable pointers. Actually, what I explained to you here is variable pointer. So what is a variable pointer? It holds, simply speaking, it holds the address of a variable. It holds the address of a variable. Same as this, we have a concept called function pointer. Can you describe it now? Variable pointer holds what? Address of the variable. Now function pointer, use your brain, guys. Simple, na? It holds the address of a function. It holds the address of a function now. So it is going to hold the address of your function. For example, I'm writing a small function like this, void fun, void test, some function. And for this function, I'm passing a parameter int a. Void function, I'm passing a parameter int a. And inside of it, I'm just going to write some logic, printf. Value of a is, if I want to substitute a value, how do you write code? C language. What we use? Percentile D. Value of a is percentile D, comma, then we just use a there. In C# we use curly placeholders, but in C language etc. we use percentile D. So value of a is, we use percentile D and a, and the value of a will come now and sit at this location. So what is this? This is a function. This is a function. Now we have a concept called as function pointer. We have a concept called function pointer. What is it? We can define a pointer on the function, and that is going to hold you the address of the function. That is going to hold you the address of the function. For example, watch it. I'm writing void main. I'm writing the main function. In the main function, I'm just going to declare a pointer now. How to declare a pointer? The written type of the function is void now. So the pointer also will have void. Name of the pointer. Name of the pointer. For example, test underscore PTR something. The name of the pointer is test underscore PTR. Okay. So basically to tell it's a pointer, we require to use star there. See on the top also star P. Here also the pointer name. And afterwards, you're required to tell what parameter the function takes. What it takes? Integer. No need to tell names. This is called function pointer. This is called as function pointer. How do you declare? If this is void, void. If this is int, int. If that is a double, double. Then a name, any name of your choice. Name is your choice. Next, what parameters are defined here? The same parameters should come here also now. If you are taking 3 parameters here, all the 3 are. No need variable, only type names. Only types. So this is a pointer. This is going to be a pointer for you right now. Okay, fine, well and good. Now, after defining this particular pointer, remember, you can call this function now in 2 ways. You can see on the top, we discuss, we can access the value in 2 ways. One is variable, one is pointer. Okay, here also, we can call the function in 2 ways. What are the 2 ways? 1, call the function directly. 2, call the pointer. How do you call a function? If you want to call a function, you can directly call test of 10, right? Calling the function directly. Calling the function directly. Option 2, we can call the pointer also. How to call? What is the pointer name? Test underscore PTR and then pass the value. Calling the function through pointer. Are you guys clear? 2 ways. There also we can access the value through I. We can access the value through P. Same way. We can call the function to its name. You can call the function through pointer. Now the question is, which one is faster? Which one is faster? Calling the function directly or calling through the pointer? Pointer. What is the advantage? Why? Direct access to? Louder. Direct access to memory. Do you use the same medicine for all diseases? I said you direct access to memory in the first one and you are telling the same thing second also. Right? We couldn't use the same medicine every time here. It's faster not because it is a direct access to memory. It is faster not because it is a direct access to memory. Okay? So it is just going to provide you a direct access to a memory is wrong. For a variable, it is right, not for a pointer. Okay? Listen. Sit down here. Next time, if you repeat, you'll be out of the classroom. Open the mouth. See, I'm talking with you normally only. See, in my other classes, still I'm very angry. I'm not showing that anger. I'm controlling a lot. But still, if you behave like this, I need to show my anger. I'm controlling a lot, not at all getting angry. And you're behaving like this. See, open up. You say right, you say wrong. But first open the mouth. Don't sit lazily in the classroom. It irritates the teacher a lot. Fine. So, the question here is, like, why is calling through a pointer is faster? Why is calling through a pointer is faster? Why is it faster? The reason behind this, why is it faster, is not like because it's a direct access to memory. Listen, a function means a set of statements, some logic inside of it. And to execute this particular logic, some logic is available in the code now. And to execute this particular logic, you need some memory. Today it is only one line here, but tomorrow you write some functions with 100 lines now. Lot of logic and manipulations. One day we written a function for converting a string into Pascal case, remember? On that day we just done a lot of manipulations on it. First we converted into lowercase. Again we broke into string array. Again we broke into character array. Again we converted the first character into uppercase. Again we just converted into string, concatenated, or a lot of logic we have written there. And to execute all this logic, memory required. Correct. So what happens, whenever you call a function, to execute the logic inside the function, operating system will provide some memory. Operating system will provide some memory. We call it as a function stack. Long back we discussed about stack, do you remember? That is program stack. Program stack means it is applicable for the whole program. But here what I'm telling is function stack. What is function stack? Function stack means it is created for the execution of a function. It is created for the execution of a function. And the scope of this, when the function execution starts, stack is created. And once the function execution is completed, stack is destroyed. So that is the scope of that particular function stack. So what is the problem is, suppose if I call a function 10 times, 10 times stack is created, destroyed, created, destroyed. All the 10 times it will create and destroy. So which is going to be a performance problem, which is going to be a performance threshold. So it is a problem here. Performance problems will come for you. Allocating, deallocating, time taking, na? So that is going to be time taking. So then whenever you just wanted to call a function for multiple times, at that the point of time, they use the concept of the pointers. They define a pointer and call the pointer. What is the advantage of calling through a pointer? No? If you call it through a pointer, basically for a pointer, there is a memory now. Whenever you declare a function pointer, there is a stack created. Even you call the function for 1 time or 10 times, all the times the code executes under the same stack. All the time the code executes under the same stack. So now creating or recreating the stack is not required. One time the stack created, all the times the execution takes place under the same stack. So it is not a direct access to memory. Understand here? Variable means value. Directly you access the memory, you can get it. Function is not a value, some logic. If you directly access the memory, logic won't execute faster. So it's not the point of direct access to memory. What is the advantage? Multiple stacks are not going to be created here. Are you clearer or not? Multiple stacks are not going to be created in this particular case. Only one stack. It is going to be only one stack that is going to be used in this case now. So the same stack only, the execution is going to take place for multiple times. That is the benefit or advantage of using function pointers in your code. Okay. Now, Coming, all this what I explained is about the C language. Now come back, listen. In C sharp also, we have variable pointers, but we declare them variable pointers and we declare them by using ref keyword. We have variable pointers in C sharp also. Yeah, we declare them by using the ref keyword. Remember about ref? In out parameter. How it works, you know? You're writing a method like this: public void math, int a comma, int b comma, ref into c comma, ref into d. Remember, we already learned it. And inside you say c is equals to a plus b, d is equals to a into b. Now you come to main. So now you come to main. What do you do in the main? You will be creating the instance of your class. Suppose obj is the instance of your class, for example. Okay, how do you call? Obj dot math 100 25. Afterwards, you will substitute two variables here. We declare them first. Int sum is equals to 0. Okay, comma. Product is equals to 0. Product or prod is equals to 0. Whatever it is, we declare. And then what we say? Ref sum, comma, ref product. Remember all these things? Listen, these two are pointer variables. These two are pointer variables. Like we declare by using star P in C language, here we use the word ref keyword. And what is this, you know? Address of. Just like we say ampersand in C language, here what we say? Ref variable. So this is address of. So when I say ref sum, what happens, you know? The address of this variable will go to C now. See, the value of sum is 0, right? But the value won't go. What will go? The address of this sum will go to C. For example, just a second. Int x is equals to 100 and y is equals to 25. Now coming here, I'm replacing 100 with x. I'm replacing 25 with y. Now when I say math of x comma y, the value 100 will go to A, the value 25 will go to B. Clear? But when I say ref sum, the address of the sum will go to C, the address of the product will go to D. Understood? Once the execution is completed, when you say C is equals to A plus B, C is a pointer variable, cannot hold a value, but you are assigning a value. The value that is assigned here, how much? 125, will be reverted back to sum. The value 2500 is reverted back to product. Clearer? Address goes there, value comes back. Look, int A, B, C, D. Here, M is equals to 100, N is equals to P and Q. What are you calling? M comma, N comma, ref P, ref Q. M, input parameter, the value goes to here. A and B are input parameters, the value goes here. N, input parameter, the value comes here. And come to ref in C, input in out. In out means you are sending the address and it is returning the value back now. Initially this 0. What you sent? Address. Got it? What came here? Address. Now function executes. When the function executes, whatever is assigned to C is redirected to P. Whatever is assigned to D is redirected to Q. So that's why once the execution is completed, what you saw earlier here? Zeros, correct? What you saw now? 125, 2500. Observe both the pictures. This is the starting, ending. Clearer or not? Understood all of you? This is how the execution will take place for you. This is how exactly the execution is going to happen. So don't forget, we have pointers in C sharp also. How do you declare them? Ref keyword. Okay, same as that. We have function pointers also in C language. Sorry, in C# language. And we call them as are you clear? We have function pointers also in C# language and we call them as what? Delegate. Now tell me, what is a delegate? A delegate is a pointer to method, not a function. C language, I said you function. When you come to C#, it is method. So what's a delegate? A delegate is a pointer to a method. So delegate. A delegate is a pointer to a method which will hold the reference or address of a method in it. A delegate is a pointer to a method which will hold the reference or address of a method. It is going to either hold the reference of the method or address of the method in it. Okay, now tell me. Okay, so these are the two things. Either we can have the reference of it, or either you can call it the address of it. It is going to hold this. So we can now call methods by using delegate. Sorry, not we can now call. We can also call methods by using delegate. And calling a method by using delegate is faster and efficient. Calling a method by using a delegate is faster and efficient. So effective usage of the delegate will improvise the performance of your methods. Clearer? Okay. So listen. In C#, we can call methods in two ways. One, by using instance of the class if the method is are you clear? By using instance of the class if the method is non-static and name of the class if the method is static. You're aware of this. You already know this. Next, by using delegate. By using delegate. And remember, both are you clear? Now the question is how to call a method by using a delegate. How to call a method by using a delegate. How do you call a method by using a delegate? Okay. Yeah. How to call a method by using a delegate. How to call a method by using a delegate. How do you call method by using a delegate? To call a method by using a delegate, adopt the below process. Adopt the below process. Step 1. Declare a delegate. First, you're required to declare delegate. You have followed 3 steps here also. Remember, first step, you're declaring a delegate here. Are you clear? Oh, I missed a point here. Is it declaring a delegate? The next thing is you're required to instantiate the delegate. How to instantiate the delegate? The address of the method should be assigned to the delegate now. I missed it. The address of the method should be assigned to delegate now. function pointer, and then call the function pointer. What is the first step? Define it, declare it. Second one, the address of the function should be assigned to this one. You can write both these two in a single line here. To understand, I read this separately. Here only I can put is equals to ampersand test. Declaration initialization on the same way. This is declaration and this is initialization. Third step, call. Now also again the same process. What is that? Declare a delegate. Second, instantiate the delegate. Third, call the delegate. Call the delegate. Declare the delegate. Instantiate the delegate. Call the delegate. Are you clear? Declare the delegate, instantiate the delegate, and call the delegate are the three things what you're just going to do now. Okay? So first let us try to understand how to declare a delegate. First let us understand how to declare a delegate. How do we declare a delegate? It is the syntax to declare a delegate here. Modifiers, delegate, void or type, name, parameter list. Modifiers, delegate, void, type, name, parameter list. Observe that carefully. It's exactly same like a method signature. Yeah. The delegate keyword extra. Are you clear? Much more clearly, it looks like an abstract method. It looks like an abstract method, a method without a body. A method without a body. But there we say abstract and here we say delegate. It looks like, I'm not telling it is an abstract method. It looks like a abstract method. Okay, this is the first step. And remember, while declaring a delegate, make sure the input parameters and the return types of the method of the delegate exactly matches with the method we wanted to call using delegate. Okay, so while declaring delegate, make sure the input parameters and the return types of the delegate exactly matches with the method we want to call using delegate. Already on the top also I said you, in the function pointer also I said you that one. Here void means here also void. Taking int means here also taking int. Thing is name. Name is your choice. You can give name. What is it mandatory? Only parameters should match. Now observe it. I'll tell you an example. Public void add int x comma int y. Console dot write line x plus y. Console dot write line x plus y. Okay now? Now this is a method. I want to define a delegate for this. Another method. Public static string say hello. Hello plus name. Are you clear? Okay, so that's how you basically do it. So public void int x comma int y, console.writeLine x plus y, public static string say hello, string name, return hello plus name. I hope it's clear. Okay. Now, listen carefully. So this is actually two methods I want to call by using a delegate. So first I'm defining a delegate for the first method. Public delegate Void. Name of the delegate. Any name, your choice. Any name here, your choice. And now you're required to pass the parameter. So two integers as a parameter. Names are not going to be important there. Types are important. Any name, that's it. To understand that only changes the names. You give same names also no problem. Different names also not problem. But only thing is, okay. Now can you understand how to define a delegate for this now? Come and try. Public. Louder. Delegate. No need. Statics and all I did not tell now. That's no need. String. Say delegate. str. That is how you define a delegate. Okay. So this is the first step. Second step. See, remember, a delegate is a type here. Delegate is a type. And every type should be instantiated. You define a class, can you consume it directly? You need to create the instance of the class. That's what instantiated. You're required to instantiate the delegate also now. How? Add delegate AD is equals to new. You create the instance, guys, add delegate. And in this process, you're going to tell the method name here. The method and the delegate are bound with each other. Otherwise, method is defined separately. Delegate is defined separately. There is no link between them at all. Yes or not? So now the two has to be linked up with each other. This is how you link it. You can write in another way also. Add delegate AD is equals to add. Like this also you can write. Understood? Come and tell the second one now. Say delegate is equals to new. Say delegate, say hello. Or say delegate SD is equals to say hello. Okay, that is the second step, or that instantiating the delegate. Third step, call the delegate. Call the delegate. You're required to call the delegate now. How do you call? AD. Calling it. I'm calling the method for multiple times. How many times I call the method? 3 times by using a delegate. If I directly call this method 3 times, 3 stacks are created and destroyed. But here only 1 stack is used. It is going to use only 1 stack. Under 1 stack only, the method is executed for 3 times with 3 different values. Sorry, with 3 different set of values. With 3 different set of values. Is it clearer or not? Next. Second one. What is that? Say delegate, SD. String S1 is equals to SD. Why? It's a value returning method here. It's a value returning method. SD of pass a value. Okay, now SD of a value. Same way. String S2 is equals to SD of passing up now. I called the method also for 3 times now. Okay, so totally how many method calls are there? 6. But the number of stacks that are created are 2, not 1. 2. Why? 2 delegates are there. So 2 delegates, 2 stacks. I am not telling all delegates will use 1 stack. I am telling you 1 delegate will use 1 stack. So 2 delegates, 2 stacks. Otherwise, if I make a direct calls to the methods now, 6 stacks. If I make a direct call to the methods, how many stacks are created? 6 stacks. 3 for 1 method, 3 for 1 method. I cannot show. Can you see memory? Ashok, can you see the memory? Then how can you see a stack now? There is no option available. Okay, So fine. So like this, we are just going to have the performance will be improvised when you go for using the delegates and calling. So look, guys. Now a small thing. Where should I define a delegate? Where should I define a delegate? Just like other types, you need to define delegates also under namespaces. Just like other types, we're required to define delegates also under namespaces. But we can also declare delegate under class or structure. Nested type. I said you the same point with enums. Do you remember? All types should be under namespace only, but enum can be defined under a class or structure also. Option is there, but what did I say? Option is there, but don't follow that. What did I say? Always go with namespace only. Now also I'm telling the same point. Delegate also. Option is there, but don't follow that. Where you define? Under namespace only. Are you clear? Yes or not? Well, Raju, are you sleeping in the classroom? I very clearly said here. I said about stacks already earlier that are program stacks. I'm not talking about this. This is different. This is function stack. Program stack is for the execution of the whole program. Long back I explained to you about stacks. That is for the execution of the whole programs. But what I'm saying here is function stack. Function stack means it is created when the function starts execution and destroyed when the function ends execution. The scope is only for a function call. That is called function stack. Program stacks are different. Function stacks are different. Program stack is for the whole program. Function stack is for only a particular function. Only for a particular function. Understood, Raju? Fine. Let me add a new class, guys. I'll name the class as Delegate Demo 1. Simply called Del Demo 1. Let's write the methods in the class. Public void. I'm just going to write int x comma console dot write line sum of given numbers is x plus y plus z. Sum of given numbers is x plus y plus z. Okay, fine. Same way, public. Just to understand, one method I declared it as static and one method as non-static. What are you writing? Return. Hello. That's what I'm just going to display. Okay, a simple message what I given. Now I got my two methods. Now I want to call these two methods by using delegate. I want to call these two methods by using delegate. Using a delegate, I want to call the two methods. Okay, come on, let's follow the process. First step, declare a delegate. Where should I declare? Inside a class or inside a namespace? Inside a, possible to define inside a class also, but better go with inside the namespace. So if I declare it here, it is inside the class. If I write here, it's inside a namespace. Public delegate. Okay, void. I'm writing a delegate called as calculator delegate. My choice. I can give any name. Okay. Int A, int B, int C. Next. For second one, public delegate string wish delegate string str. String str. Got it? So these are the two delegates I defined. First step completed here. What is the first step? Declaring the delegate. Second step, instantiate the delegate. Instantiation. Where do you do instantiation? Main method. Instantiation is always done in the main method. Come on, let us go to main method. Let's go for instantiating. How to? First we'll start with wish delegate here. First we'll start with wish delegate. Wish delegate is equals to new wish delegate. Guys, listen here. When you're creating the instance here, it will show you what the target method should have a string input and string return type. This indicates return type. This indicates input parameter. So what should be the input parameter? String. What should be the return type? Any method that matches can be passed here. Any method that matches the signature can be passed here. And right now, what method is matching here? Our say hello is matching. Clearer? Huh? Say hello is matching. Next, WD of printing the name. And the value returning method. So what I'm writing? Console dot write line. Every time creating and destroying is easier. It's a time-taking process here. And see, once the execution completed, the stack gets cleared. It won't keep the memory like that. So no issues with it. So you got the output. You just got the output over there. Are you clear? Okay, so fine. Now you just got executing the things for 3 times and you just got your results. Now let us try with calculator delegate. Method name. A method that has a void return type and 3 integers can be passed here. What is the method name? Add nums. But giving error, see? Error. Why? Say hello did not give error, but add nums is giving error. Can you tell me why? There is no error with say hello, but you have an error with add nums. Add nums, 3 integers. Add nums has 3 integers only. Non-static members of a class cannot be directly accessed in a static block. Na? You're forgetting the basics also. You remember that? CLO is static. Static to static, direct access. So that's why it is coming. Add nums won't come. Why? Addendums is non-static and main is static. Non-static members of a class cannot be directly accessed in the static block. How they can be accessed? Only by instance, only by prefixing with the instance. So that's why first create the instance of your class. Now, no error, see. CD off. Calling. Can see. Are you clear? So totally we have 6 calls, but internally the number of stacks that are created will be 2, not 6. Not 6. Are you clear with the 3 steps? So first step. Second step, instantiate, not initialize. Instantiate the delegate. Third step, call the delegate. You can write in a simple way also. Without writing this much, you can say simply obj dot addendums. Simple way. Here also, say hello. But generally, you know this, remember, what's it? Like static members are prefixed with class name. Non-static members with instance. See, non-static, so with instance. Static with class name. You can observe the code. You can test performance writing complex coding inside here. When you write 1 line, 2 lines of code, you won't find any difference in the performance. Okay? Fine. Are you clear? So basically, what is the delegate? Delegate is a pointer to a method. So now you can call methods by using the delegate. Entry of .NET Core, all questions came from your notes. I said, object-oriented programming, if you are perfect, you can clear 70% of the interviews. If you are perfect in object-oriented programming, you can clear 70% of your interviews, basically. So, yeah, and the one, you just got the job, right? Yeah, he also got a job. What did they ask you? Oops, yeah, they ask you only oops only. You already got a job. It's just going to join from Monday. I said you in the starting lab, one of the classroom student, also online students, for all the classroom student also got a job already. Most of the people in the .NET get recruited when they are completing their course only. Opportunities are very good. You should be good in the oops. If you are good in object-oriented programming, that's enough. You will easily crack the interview because as a fresher, they don't expect you lots of things here. What they expect is only, are you good in the fundamentals or not? If you're good in fundamentals, that's enough. Understood? That's what I'm telling you. Put your efforts first. Okay? That's what I scolded last week only. Array, don't be irregular in the class. But still you people are repeating the same thing only. What should I say? LKG students are better than you. You're grown up and you should not miss the classes I'm telling, and you're still missing the classes, bunking the classes. One day you come, one day you absent. Are you coming for me? Are you coming for me? If you don't come, any loss for me? I don't have any loss here. I don't have any loss. You already paid the money. And I just get my salary. And this is not only my thing. I have a job. I have a job. I'm well settled. Teaching is my passion. Teaching is my passion. Because of the passion I teach. That's all. Because actually, doctors have suggested me not to teach. From 15 years I'm teaching. I have throat problem. That's why I just stop teaching in the evening times. I stopped teaching. I was teaching only morning times because there is a passion. I can't leave that. Because of that, I'm well settled. I don't require to do a job at all first. I got all my earnings, what I earned. I have invested in my properties. I get regular monthly income. I can sit at home and eat. I don't require to teach at all. Okay, but it's a passion, just for a passion to make, see, like others coming into the market. I want to helping them to just to succeed in the market. So that's what, with the passion, I'm just doing the work. And you just coming to class as if you are just going to give some, I am going to be benefited. I am not benefited. You are benefited. Remember that. Be regular in the class. What is the so problem coming to the class for you there? What do you do in the hostel? Sleeping? Sleeping, huh? What do you do in the hostel, guys? You came to Hyderabad for learning classes and you see sleeping in the hostels. So that attitude should change first. You want to settle, you should work hard. Without hard work, you cannot expect of getting the jobs and settling off in the market. Be regular. Online students also, when the class starts, 105, 106 people I see. By middle, I see only 95 people. Remaining 10 people are very busy, going up somewhere. 1.5 hour, not even 1.5 hour, yeah, maximum I'm taking a class for 15 minutes, right? 1 hour, 15 minutes, you're not able to sit in the class. You're not able to attend the classes regularly. And you want to get off a job and you want to get good salaries and enjoy your life. You won't put your efforts. Without putting the efforts only, you want all these things. That's not right. You're not in the right track. Correct yourself first. Okay. So are you clear now how you use a delegate? We'll talk some more examples on the delegate in the tomorrow session. Let's stop it. We'll meet tomorrow.
Recording stopped.